In this section, we're going to start talking about what are called functions. Now, you might have heard the word function before, as in if something functions, it works properly. If something doesn't function, it doesn't work properly. Take this calculator, for example. If I press the 8 button, I want an 8 to appear on there every single time. If I press the 8 button and I get something different, then the calculator ceases to function. In mathematics, we define it this way. Every single input has exactly one output. That means every single time you do something, some action or some input, you have the exact same result. So back to the calculator example, every single time I press 8, I want an 8 to appear on the screen. That's what makes it a function. Every input has exactly one output. That's going to be the answer for every question for this video. Now, we have a lot of examples of different relations here where we have an input that goes to an output, and this is called a mapping right here, so we can see that 2 as our input goes to 1 as our output, 4 goes to 3, 7 goes to 5. Our question is this a function? And we're going to go back to the definition every time. Does every input have exactly one output? Well, 2 has exactly one output, 4 has exactly one output, and 7 has exactly one output. Now you notice that I don't mention what the value of that output is. I don't actually care. I just need to know that that one input has exactly one output. And that's the case for each of these, 1, 1, 1. So yes, this one is a function. Our next example right here, we can see that 3 has one output, 4 has one output, but 6 has 2 separate outputs. So this right here makes it so it is not a function. 6 has 2 separate outputs. So no, this one is not a function. Our third example right here, we can see that 5 has an output, 6 has an output, and 8 has an output. I see this one getting people mixed up a lot because it looks very similar to the last one. Let's analyze. Does each input have exactly one output? Let's take a look at the 5. I'm not worried about these. That 5 has exactly one output. It's the 4 right there. 6 has exactly one output. I don't care that that output is the same as what the 5 is. I only need to know that the 6 has exactly one output. And the 8 has exactly one output. So yes, this one is a function because each one of these has exactly one output. It doesn't matter that they're all the same output. That's okay. All right. Here we have a set of values, a set of ordered pairs. We need to know something about inputs and outputs. Inputs are the x values, and the outputs are the y values. This will be important for our graphs and for our table of values for lots of things moving forward. So let's take a look at the inputs and outputs and see if each input has exactly one output. All right, 2, the input has exactly one output. It's a 2. 4 has one output, -1 has one output, and 5 has one output. Each of these inputs has exactly one output, so yes, this one is a function. This one is not a function, but it's harder to see than in the mapping because right here we have 3 with an output of 1, and 3 has an output of 7. So if I was to write this as a mapping, our input of 3 actually has 2 separate outputs, 1 and 7. So that right there messes this up. This is not a function, so no, this is not a function. Now these are all okay. 0 has one output and 2 has one output, but if we have one example, one input that has something different than that, it is not a function. So yes, this is a function. No, this one is not a function.
Ms. Nielsen, please come to the main office.
Good timing on that interruption. All right, let's take a look at these two table of values right here. We again have x's and y's. X is our input and y is our output. -4 has one output, -3 has one, -2 has one, 1 has one, 0 has one, and 1 has one. This is a -1, sorry. -1 has one. So each of these inputs has exactly one output. Again, this is yes. This one is not a function. So like the last one, we have to find the input that does not have one output. And in this case, there are actually a couple of different things. The 5 right here shows up in 3 different places, and each time it has a different output. So we have one output, a second output, and a third output. The 5 actually has 3 different outputs, which makes this not a function. The 7 also messes this up. The 7 has two different outputs, -1 and 10, so both of those inputs mess this up. This is not a function. Now, we could have actually stopped after the 5, that was enough, but just to highlight that we could have looked at the 7 as well. All right, on a graph, we've got to be able to analyze our x and our y values. Let's take this point, for example. Its input is the x value, and its output is the y value. So if I was to write this as an ordered pair, it would be -3 and +1, where -3 is our input and +1 is our output. -3 has no other inputs or outputs right here. It's just that single point, so this one is okay. This right here, -2, has a single output. This point has an input of 0 and an output of 3. This +1 has a single output. This +2 has a single output, and this +3 also has a single output. So this one is a function, yes, because every input along here has a single output. It might help you to write it as an ordered or a table of values. You can do that if you wish. We're going to show what's called the vertical line test in just a second, which helps me to see that. Now this one is an example that is not a function. Let's take a look at these 2 points right here. Their input is both -3. So we have an input for these 2 points that are both -3. The output for this one is 1, and the output for this one is 3. So -3 has 2 separate outputs. We can see that happening here with the -1, where it has 2 separate outputs. At +1, we have 2 separate outputs, and at +3, we have 2 separate outputs as well. These are okay right here, but those 3 here, here, and here, in addition to this one that we saw already, make it so it is not a function, so this is no. Now you'll notice that each of these places where it messes up, we've got points that are stacked on top of each other in a vertical line. That brings us to what's called the vertical line test. If you can ever draw a vertical line through multiple points right here, it is not a function, because that means that this one input, -3, has 2 separate places where it appears with different outputs. Same here, and same here. So if we ever see that visual with 2 points stacked on top of each other in a vertical line, it is not a function. Let's take a look and use that right here. We're going to go along and see if this vertical line crosses our graph twice at any location. So as we move along, we can see it's only crossing our graph once. Everywhere along here, it only crosses our graph once. Now the graph we're talking about is this V shape right here. So this is a function because there are no points stacked on top of each other, or it passes the vertical line test. So yes, this is a function. Taking a look at this next one, we can see if we put a vertical line here, the graph crosses that vertical line in multiple locations. So this vertical line, for example, crosses here and here, but there are infinitely many places that we can put that vertical line and see that it crosses at locations. This one is not a function because we've got points stacked on top of each other. In other words, this input has an output up here and an output down there. It's got 2 separate outputs. Let's take a look at our last graph right here. Using the vertical line test, we can see that the graph intersects only once on this vertical line everywhere. So this one is yes, there are no places where points are stacked up on top of each other. So this is a function. There are infinitely many examples, so make sure you're taking a look at inputs and outputs. Your reason will always be either every input has exactly one output, so yes, it's a function, or it is not a function because we've got some input that has more than one output. And it is not, that makes it not a function. Thank you.